Welcome back. Today's video is based on the Force and Laws of Motion, Chapter 8, Class 9. Before starting this video, please like and subscribe to my channel LinkedIn Pharma. Let's start it. Introduction on Force and Laws of Motion. Force and the laws of motion are fundamental concepts in physics that describe how objects move and interact with each other. These principles, formulated by Sir Isaac Newton in the 17th century, provide a framework for understanding the relationship between forces, motion, and inertia. In this brief introduction, we will explore the key ideas behind these laws and how they govern the behavior of objects in our everyday world. Balanced and unbalanced forces. Balanced and unbalanced forces are fundamental concepts in physics that describe how forces acting on an object affect its motion. Let's explore each concept with examples. Balanced forces. Balanced forces are forces that cancel each other out when acting on an object. When the net force on an object is zero, it remains at rest if it was initially at rest, or it continues to move at a constant velocity if it was already in motion. In other words, balanced forces result in no change in an object's state of motion. Example: imagine you are pushing a book across a table with a force of 5 newtons to the right. Your friend is pushing it with an equal force of 5 newtons to the left. In this case, the forces are balanced, and the book remains in place. It doesn't accelerate in any direction because the net force is zero. Unbalanced forces. Unbalanced forces occur when the forces acting on an object do not cancel each other out. When there is a net force acting on an object, it will accelerate in the direction of that force. In other words, unbalanced forces result in a change in an object's state of motion. Example: consider the same book on the table, but this time you push it to the right with a force of 5 newtons, and your friend isn't pushing back. In this case, there is an unbalanced force of 5 newtons to the right. As a result, the book accelerates to the right in the direction of the force you applied. In summary, balanced forces lead to no change in an object's motion, while unbalanced forces cause objects to accelerate in the direction of the net force. These principles are essential in understanding how objects move and interact in the world of physics. First law of motion. The first law of motion, also known as Newton's first law or the law of inertia, is a fundamental principle in physics formulated by Sir Isaac Newton. It states, an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by an unbalanced external force. In simpler terms, this law highlights the concept of inertia, which is the tendency of objects to resist changes in their state of motion. Here's a breakdown of the key points in the first law. Objects at rest. If an object is initially at rest, not moving, it will remain at rest unless an external force is applied to it. In the absence of any force, objects prefer to stay motionless. Objects in motion. If an object is already in motion, it will continue to move at a constant speed and in the same direction unless an external force acts upon it. In other words, objects in motion tend to stay in motion. Unbalanced external force. To change the state of motion of an object, to make it start moving, stop moving, or change its speed or direction, an unbalanced external force must be applied. This force is required to overcome the object's inherent tendency to maintain its current state of motion or rest. Example: imagine a hockey puck gliding smoothly across an ice rink. If there are no external forces like friction or a player's stick pushing it, the puck will continue to slide at a constant speed and in the same direction due to the first law of motion. If you want to stop the puck or change its direction, you need to apply an external force, such as pushing it with a stick. In summary, Newton's first law of motion underscores the concept of inertia, explaining how objects naturally behave when no external forces are acting on them. It serves as a foundational principle for understanding the dynamics of motion and forms the basis for the other two laws of motion formulated by Newton. Activity: the balloon-powered car. Materials needed: a toy car with wheels, a balloon, a drinking straw, tape, scissors. Steps: attach the drinking straw to the back of the toy car using tape. Ensure that the straw points in the direction you want the car to move. Blow up the balloon and pinch the opening to keep the air inside. Attach the mouth of the balloon securely over the end of the drinking straw, making sure there are no leaks. Place the car on a smooth, flat surface, such as a table or a floor. Release your fingers from the balloon's opening, allowing the air to rush out through the straw. Observe what happens to the car. Explanation: in this activity, you'll see Newton's first law in action. The car remains at rest until an external force is applied, which is the air escaping from the balloon. When you release the air from the balloon, it rushes out in one direction, propelling the car in the opposite direction due to the principle of action and reaction, Newton's third law. Initially, the car is at rest, representing the idea that objects at rest tend to stay at rest. However, when you release the air from the balloon, the car starts moving because of the unbalanced force generated by the escaping air. Once again, this demonstrates how an external force is needed to change an object's state of motion, in line with Newton's first law of motion. Inertia and mass. Inertia and mass are two closely related concepts in physics that describe how objects behave with respect to motion. Let's delve into each concept and understand their relationship. Inertia. Inertia is the property of an object that resists changes in its state of motion. It is essentially the tendency of an object to stay at rest if it's initially at rest or to continue moving in a straight line at a constant speed if it's already in motion. In other words, inertia is the resistance of an object to acceleration or deceleration. Key points about inertia. Dependent on mass, the inertia of an object is directly related to its mass. Objects with more mass have greater inertia, meaning they are more resistant to changes in motion. Conversely, objects with less mass have less inertia and are easier to accelerate or decelerate. First law of motion. Inertia is a fundamental concept underlying Newton's first law of motion, the law of inertia. This law states that an object will remain at rest or in uniform motion unless acted upon by an unbalanced external force. In other words, the inertia of an object causes it to maintain its current state of motion unless an external force changes it. Mass. Mass is a measure of the amount of matter contained in an object. It is a fundamental property of matter and is typically measured in units such as kilograms or grams. Mass is different from weight, which depends on the gravitational force acting on an object, whereas mass remains constant regardless of the gravitational field. Key points about mass. Scalar quantity. Mass is a scalar quantity, which means it has magnitude, a numerical value, but no direction. It tells us how much matter an object contains. Invariance. Mass remains constant regardless of an object's location in the universe. An object with a mass of 1 kg on Earth would also have a mass of 1 kg on the Moon or in outer space. It is an intrinsic property of the object. Related to inertia, as mentioned earlier, mass is directly related to an object's inertia. Objects with greater mass have more inertia and are more resistant to changes in their state of motion. In summary, inertia is the property of an object that resists changes in motion, and it is directly proportional to an object's mass. The more massive an object is, the greater its inertia, and the harder it is to change its motion. Understanding these concepts is crucial in comprehending the behavior of objects in response to forces, as described by Newton's laws of motion. Second law of motion. Certainly, Newton's second law of motion is a fundamental principle in physics that relates the force applied to an object, its mass, and its resulting acceleration. It is typically expressed as follows. The acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Mathematically, this law can be written as F equals ma, where F represents the net force acting on the object, measured in newtons, n. M is the mass of the object, measured in kilograms. A is the acceleration of the object, measured in meters per second squared, m per square second. Key points about Newton's second law. Force and acceleration relationship. This law tells us that the acceleration of an object is directly proportional to the force applied to it. If you apply a greater force to an object, it will accelerate more. If you apply a smaller force, it will accelerate less. Inertia. It also highlights the role of mass in the equation. Mass is a measure of an object's inertia, which means that the more massive an object is, the harder it is to accelerate. Therefore, the acceleration of an object is inversely proportional to its mass. In simpler terms, heavier objects require more force to accelerate at the same rate as lighter objects. Direction of force and acceleration. The direction of the force applied determines the direction of the resulting acceleration. If the force and acceleration have the same direction, the object speeds up. If they have opposite directions, the object slows down or decelerates. Example: imagine pushing two shopping carts, one empty, low mass, and one filled with heavy groceries, higher mass, with the same force. According to Newton's second law, the cart with groceries will accelerate less because it has more mass. The empty cart, lower mass, will accelerate more for the same force. In summary, Newton's second law of motion provides a mathematical relationship between force, mass, and acceleration. It explains how the application of force to an object with mass results in a change in its motion, either in terms of speeding up or slowing down, and it forms the basis for calculating the effects of forces on objects in the real world. Mathematical formulation of second law of motion. Suppose an object of mass, m, is moving along a straight line with an initial velocity, u. It is uniformly accelerated to velocity, v, in time, t, by the application of a constant force, F, throughout the time, t. The initial and final momentum of the object will be, P1 equals mu and P2 equals mv respectively. The change in momentum proportional P2 minus P1. Proportional mv minus mu. Proportional m into v minus u. The rate of change of momentum proportional m into v minus u by t. Or, the applied force. F proportional m into v minus u by t. F equals com into v minus u by t I. F equals kma e. Here R equals v minus u by t is the acceleration, which is the rate of change of velocity. The quantity k is a constant of proportionality. The SI units of mass and acceleration are kilogram and ms2. Respectively. The unit of force is so chosen that the value of the constant, k, becomes 1. For this, 1 unit of force is defined as the amount that produces an acceleration of 1 meter s square in an object of 1 kilogram mass. That is, 1 unit of force equals k into 1 kilogram into 1 meter s square. Thus, the value of k becomes 1. From equations 2, F equals ma. The unit of force is kilogram ms square or Newton, which has the symbol N. The second law of motion gives us a method to measure the force acting on an object as a product of its mass and acceleration. The first law of motion can be mathematically stated from the mathematical expression for the second law of motion. Equation 3 is F equals ma, or F equals m into v minus u by t. Or Ft equals mv minus mu. That is, when F equals 0, v equals u for whatever time t is taken. This means that the object will continue moving with uniform velocity, u, throughout the time t. If u is 0, then versus will also be 0. That is, the object will remain at rest. Third law of motion. Newton's third law of motion, often referred to as the law of action and reaction, is one of the fundamental principles of classical physics. It states, for every action, there is an equal and opposite reaction. In simpler terms, this law means that whenever one object exerts a force on another object, the action, the second object exerts an equal force in the opposite direction on the first object, the reaction. Key points to understand about Newton's third law. Pairs of forces. The third law deals with pairs of forces that act on two different objects. These forces are equal in magnitude and opposite in direction. Action and reaction. In the context of this law, action refers to the force applied by one object, and reaction refers to the force exerted in response by the other object. These forces always occur simultaneously. Equal magnitude, the action and reaction forces have the same magnitude, which means they are of equal strength. If one force is 10 newtons in a certain direction, the other is also 10 newtons in the opposite direction. Opposite directions. The action and reaction forces act in exactly opposite directions along the same straight line. If object A exerts a force on object B to the right, object B will exert an equal force on object A to the left. Example: consider two ice skaters on a frictionless surface. When skater A pushes skater B to the right with a certain force, skater B, in turn, exerts an equal force on skater A, pushing them to the left. Both skaters move in opposite directions due to the action and reaction forces. This law is crucial in understanding the behavior of objects in the presence of forces and is applicable to a wide range of situations, from simple everyday scenarios to complex mechanical systems. It also explains phenomena like the propulsion of rockets, where the action is the expulsion of gas and the reaction is the forward motion of the rocket, and the operation of vehicles, where the tires push backward on the road, and the road pushes the vehicle forward. Thank you for watching. Please like, share and subscribe.